Good morning, lovely 12s. Right, buddies, here we are again in our next part of the trig unit. So you guys were really good last time at solving equations, basic trig equations, and finding both solutions, really. So you used cast, probably many of you used cast to do it. Some of you still on the graphs. It's all good, one way or the other. And yeah, because you could do that amazing skill, the cast skill in the getting multiple solutions, we're ready for the next thing. These are the hardest ones, and it's trig equations with an altered period is your title. Or if you don't want that as a title, you can just put down hard trig equations. That's good as well. Cool. Right, buddies. So I'll show you what I mean by having an altered period. If you check it out, in all of the previous ones, you've done things like I don't know, like cos of theta equals like 0.5 or sine of theta equals 0.2. Stuff like that you've done. But if you check it out now, here's the difference. Can you spot that this is cos of 3 theta? Good. Now, if it's cos of 3 theta, you know from the graph transformations unit that what effect does that have? What is the actual graph transformation there if you replaced a theta with a 3 theta? Well, if you said it's a horizontal squeeze by a factor of 3 or a horizontal stretch by a factor of 1/3, you're absolutely right. So in other words, if it's going to be squeezed by a factor of 3, we're going to fit 3 of them in the spot where we normally fit 1. So I've been on autograph now just to show you guys what it looks like. So if you check it out, I've just drawn it. So it's not drawn, but it's like perfectly accurately drawn with the with autograph, so it's not by my hand. And with autograph, here's what we've got. This red here is your regular cos graph. If you check it out, I've got it counting on in 90s, so 90, 180, 270, 360, because good stuff always happens in 90s in trig. And check it out. Cos, as you know, would just go down through 90, bottoms out at 180, back up at 270, finishes off in 360. So that is like one go of cos. That's like one iteration of cos, or one wavelength of cos, if you cos kind of thing, if you want to think of it that way. It's one iteration of cos. Now, here's the thing. If this is cos, then that means this. The cos of 3x, the cos of 3 theta, you're going to fit 3 of them in the same spot that you fit 1 cos. And you can confirm that that's true. So look at, there's one of it, there's another of it down the middle, and there's a third of it down the middle. Cool? So hopefully not very surprising, but nice to actually see. That's what I'm going for now. So it's going to have an impact though on us, because it's going to change our solving. So if we want it to equal 0.766, here's the thing. Well, just make up anywhere where you think it might be. I'm going to put it there, even though it's clearly higher than that, but I want you to see it hitting better. 0.766, check it out. If you drew a line across from that, like thinking about the graphs method, what you would find is on cos, you get 2 answers. One answer there, one answer there, okay? So on cos, we're going to get 2 answers. But on cos of 3 theta, as opposed to just theta, we've got 1, 2, 3, 4, 5, 6 answers. So what you've found is there's way more answers when you've got an altered period, okay? There's 3 times as many if the thing had a horizontal squeeze of a factor of 3. So yeah, it's going to affect our work. Now, lucky for you, I think in the first question I will show graphs method and cast method. Cast is better though, for sure, in this instance. But I will show you both methods, and lucky for you, we've got a nice shortcut way of doing it, so you won't be messing about with distances on the blue graph, and you won't end up having to even ever draw a graph like that, okay? So you won't even have to draw a big horrible graph like that. Cool, so here we go. Solve the equation. This is the exact same question, that's this question, just with more space. Solve that equation in the interval. Okay, here's what you're going to do, buddies. It's going to be exactly the same as last time, okay, to start with. Okay, so I'm going to do cast method first on the left-hand side here. Cast. Okay. Now the question we're asked to do is this. We're doing cos of 3 theta equaling positive 0.766. So it's ready to go already. Don't worry about the 3 theta. Just pretend it's not there. Just pretend it's regular theta. And regular old cast method. So here we go. Sex and the city. Now, here's the thing. Cos of 3 theta is positive 0.766. So where is cos positive? Well, here in A, where they're all positive, and cos is positive in C, because that is literally where cos is positive. Draw a stick into each quadrant. 1, 2 sticks. Dash, 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 dash. Now, still ignoring the 3 theta, my lovelies. We're ignoring it, and it's wonderful. You're going to write this. You're just going to do cos minus 1 of 0.766. Even if it were negative, we'd still enter it positive. So here we go. Shift cos of 0.766, oops, 0.766 makes 40 degrees. Okay, to 3 significant figures, it's 40.0, but I'm just going to call it 40 out of convenience. So 40 degrees. So that's 40 degrees, and that's 40 degrees. Now, same as last time, right? So far, so good. Here's where it gets a little bit different. Our first solution then, buddies, is this one, at 40 degrees, right? But the only difference is, it's not actually theta that equals 40 degrees, but 3 theta that equals 40 degrees. Cool beans? And similarly, it's not theta that equals 360 less 40, so 320. It's not theta that equals 320, but 3 theta. So here's where it's come in, okay? The 3 theta has made its first appearance here and here. So we've done exactly the same steps, but instead of theta equals 40 and theta equals 320, and that being the answer to the whole question, rather than that, what we've got is 3 theta equals both of those. Now here's what I'm going to say to make your work tidy. This is called a mathematical implication sign. If you do an equal sign with an arrow on it, it is an implication sign. It means that it follows that. Okay? So in other words, 3 theta equals 40. That means, or it follows that, theta is equal to 40 divided by 3. And let's go with 13.3. 13.3 degrees. And it also means on this one, it follows that. If 3 theta is 320, 320 divided by 3 is 106.7. 106.7 degrees. Okay, now you don't need to know the terminology at all, but I'm going to be saying it, so I'm going to make sure that you do know it. See these guys here, the first two answers? So you've got the one that came about from 40 and the one that came about from 320, the 13.3 and the 106.7. These guys are called principal solutions. These are the first two solutions from the first wave of cos, okay? They are these solutions. They match up with this here. This is your 13.3, and this is your 106.7 or whatever it was. 106.7 was it? Yeah, 106.7. Those are your principal solutions because they're on the first version of the cos. Do you see what I mean? Of the blue one. So bang, we got our principal solutions. Now that's not all of them. There's a whole bunch more solutions to get. So in order to get the other solutions, here's what we got to do. We're just going to add on 1 period to each of these solutions. Now the thing is, the period has changed, okay? Now normally, the period being how many degrees for a repetition, okay? In case you don't remember what period is, it's how many degrees for a repetition. Now normally, for cos, it's 360 degrees to make it repeat, right? But if it's 3 theta, it's got squeezed by a factor of 3, which means it's going to be 3 times as many in. So what we're going to do is we're going to divide by 3. It means that it only takes 120 degrees for cos to repeat itself. Now, here you go, my buddies. I'm going to give you a bit of a tip again, so I'm going to try to make it easy for you. I hope that makes sense. That's the real reason why it works, is because it's 360, the normal period, divided by 3, because it's a horizontal squeeze by a factor of 3. That's the actual answer. Now, dodgy answer to help you remember. Check it out, lovelies. It's 3 theta divided by 3. Done. Okay? If it was a half, you'd divide by half, and it'd be 720. If it was 4, you'd do 360 divided by 4, and you'd get 90. Get me, buddies? So you just divide by whatever the number is that's touching the theta. But the reason for that is because you're fitting 3 times as many waves in, so of course you'd have to divide by 3. Okay. Your final step then, now that you know what the period is we're going to take our 2 principal solutions, and we're going to add 1 period onto each one until we leave our range. our range of 360 degrees. See, I told you these are the hard ones. So what you're going to do then is this. You're going to start off with adding 120 degrees, so we'll go plus 120, just so you can see, to that. So you're going to go 13.3. 13.3 plus 120 equals 133.3. 133.3 degrees. Okay, are we too big for the range yet? Are we out of the 360, out of the top? Well, no. So what we're going to do is we're going to add it again. Now, because I've got it typed into my calculator, that is just a quick other step, and you get 253.3. 253.3. Okay, are we still within our range? Are we still under 360? Well, yeah, we are. So we'll add another one, plus 120. And this time, I've got 373.3. 373.3. Now, is that in our range? No, it's out the top. So we don't want it. So you don't even have to write it, to be honest. Get rid of it. It's too big. Cool. Same deal on this one. 106.7 is the principal solution. Add 120 to it. So 106.7 plus 120 plus 1 period. 226. 226.7. Okay, still in the range. So add another period plus 120. Now we've got 346.7. 46.7. And if I added another period to it, I'd be out the range, right? So that's it. There you go, buddies. This is all 6 answers, okay? That's the answer to the question. Now, because we want to make our examiners love us, and we want to make sure that we're getting all the marks we can, to make it simpler for your examiner, now what you'll do is you'll write them out in order from smallest to biggest. So that means 13.3 is an answer, 106.7 is an answer, 106.7 is an answer, 133.3 is an answer, 226.7, 226.7, 253.3, 253.3, and 346.7 degrees. That is the answer to this entire monstrosity of a question. Okay, so again, the steps were the same down to here, but then what you had to do is divide by whatever the period was, because it wasn't theta that was equal to 40, but rather 3 theta, giving you your 2 answers, the 2 answers being called the principal solutions. Then you said to yourself, to get answers that are further along the wave, all I have to do is add one more wave to where I am, because that's how many degrees it takes for it to repeat. So the next solution will be that many degrees along. And so we figured out that the period was 360 divided by 3, because we're fitting 3 of them in where we'd normally fit 1. That means the period was 120. So you added 120 onto your first principal solution to get that, then 120 again to get that, but then 120 more put us out of the range, so we weren't interested in that. Then we did the same down here. Final answer, written out in order. Done. So, hard, I know, I get it's hard, but it is good though, okay, my buddies? It's a good question. Now, really, I guess one more time, just really quick, just in the interest of showing you, see the 13.3? Check it out. If you added 120 degrees to this, that's one version, right? That means this 133.3 matches with this. Cool. And then if you did a different one, if you did the 106.7, it would match with that, okay? It's because the distance between each of these is 120 degrees, because we determined that that was the period, okay? That's how it works. Okie doke, so there it is graphically as well. Cast is way better for this. I'm going to show you it just real quick with the graph method, but I'm only just going to add bits and bobs to it. Okay, if you want to do it with graphs instead, here you go. Whatever you do, for the love of God, don't draw the actual stretched graph, okay? You're going to draw a regular coast graph. Got me? So if you want to do it that way, if you're going to do it with graphs, just one version of regular coast, okay? Draw your thing at 0.766 or whatever it is, so there you go. 0.766, okay? Giving your 2 principal solutions of here and here. This is the 40. And this is this distance is 40 as well. And so since that distance was 40, this distance is 40, so it's 40 fewer than 360. So this is 320, and then from there, from your 320, so there it is with the graphs method. I'm going to make it prettier. 320 degrees. Okay, so from your graphs method, those are your two answers from the graph. And now the question becomes exactly the same. You go from here to here. So the only difference between the graphs method and the cast method is this center step, okay? Whatever you do, never, ever, 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 ever draw like 3 versions of coast like that. If you're doing that, you're like asking for trouble. So don't do that, okay? Just do it this way or that way. Cast is better though. Cool, sweet, happy? Okay, sweet, here we go. I reckon you can do this one. So what I'm going to say is in both of the next 2 questions, I want you to pause and get ahead of me. Pause, go. Okay, and you're back. So now that you're back, buddies, what I'm going to do is I'm going to talk through it, but I'm going to talk through it, I hope, rather quickly. So here's what you've got. 2 sine of 2 theta equaling cos of 2 theta. I hope that you remember that sine over cos was tan, so I'd have divided both sides by cos of 2 theta first. Cos 2 theta over cos 2 theta means I'm going to be left with 2 tan of 2 theta equaling 1, which means that tan of 2 theta is equal to 1/2, and that means I'm ready to solve. Straight into cast. Sex and the city. I say to myself, 1/2 here on this side is positive, tan is positive here and here, so those are going to be my principal solutions. Those are going to be what my principal solutions are. Whack a stick into each quadrant, whack a stick into this quadrant. Now, no matter what the question was, no matter what, I'm going to go tan minus 1 of positive 1/2. So it is positive in this case, but if it wasn't, I'd still have put positive in. Shift 10.5 equals 26.6. 26.6 degrees, which means this is 26.6 degrees, and this is 26.6 degrees. Okay, here's where it veers off. The thing is, though, it's not theta that equals 26.6 there. It's actually 2 theta that equals 26.6 degrees. And similarly, all the way around to here, it's not theta that is going to equal 180 plus 26.6, but it is going to be 2 theta that equals 180 plus 26.6, which is 106.6. Boom, principal solutions. Then I have to say to myself, oh no, there's a period problem because the 2 thetas mixed up the period too, so I can't be adding on a period until I know what the new period is. So here we go. Period. Tan's normal period is equal to 180, right? But we're going to fit 2 of them in, so we'll divide by 2, which means its new period is 90 degrees. That is what we're going to start by adding on. Here we go. 26.6 plus 90. 26.6 plus 90 is going to make, well, it makes the same as that one. Oh, 26. Did I type it wrong? Oh dear, have I made a mistake? 106.6, 26.6 plus 90, 116.6. It's supposed to be the same as that. I made a mistake. 180 plus, it was 26.6, right? 1 plus 26. Oh, I know what I've done. 26.6 is 180. Look, I've got a mistake, my buddy. Apologies. Oh, I hope you skipped ahead now. This is embarrassing. That's wrong. See that? Wrong. 180 plus 26.6 isn't 106, is it? No. Get rid of that. Silly mistake. Okay. Oh, now it says PowerPoint is saving a recovery file. Oh dear. Okay. So here we go. Sorry about that, buddies. It's 180 plus 26.6 is 206.6. Apologies. Cool. But anyway, the 90 is still right. So let's keep going, okay? Apologies for that. 26.6 plus 90. Oops. 26.6 plus 90 equals, next one is 116.6. So our next one is 116.6, so that's fine. Plus 90 again. And, oh, we actually got to this one, 206.6. So actually we've matched up there, okay? This is matching the bottom one. No bother though, plus 90 equals 296.6. 296.6 plus 90 again is out of the range at 386. It's out of the range. Okay, now here's something neat. Tan does this every time. See, the other answer is 206.6. If you took 90 from that, you'd get to 116. If you took 90 from that, you get to 26. If you add 90 to it, you get this. So my buddies, these are actually going to repeat one another. And actually, it's because of how tan looks. It's because tan's weird. It hasn't actually got two solutions per range. It's like, since tan looks like this, you're only getting one solution per interval. See what I mean? If you come along, it only hits once per interval. So yeah, it's a funny property of tan. But anyway, there you go. Final answer then, buddies. You just jot them out. So theta equals smallest to biggest, 26.6 degrees, 116.6, 116.6 degrees, 206.6 degrees, 296.6 degrees, and there you have it. Okay, that's all of them. So actually, you didn't get way more answers in 10 as you normally do with the other two. Cool. Final question. Shaboosh. Final one. Okay, so people are back with me now. What you've got is this one. Solve that equation. Sine of 2x plus 60 equals 0.3. The range is different, though, between 0 and 180. Okay. All they've done is added a second transformation on. Because we're sick at the cast method, this literally is no bother to us at all. This is just the same as any other question to us. So the only thing that's different to us here is the 180. So here we go. Sine of 2x plus 60 equals 0.3. Because we're cast ledges, this is no bother. We're just going to pretend that this entire rubbish here is just theta, and we'll get the same answer. So here we go. Starting off with step 1, it's already in a nice format. It's already sine of something equals something. So sex and the city. It's positive 0.3, which is positive. Sine's positive in S, and sine's positive in A. Whack a stick into each. Dash, 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 dash. Stick into there, dash, dash, ooh, dash, 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 dash. Stick into there, dash, 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 dash. Now, here we go. No matter what the thing is, I'm always going to go sine minus 1 of the positive of it. So positive 0.3, shift sine of 0.3. If it were negative, I'd have done positive as well. I know I keep saying that, but just so you remember. And this is 17.5. Okay. So this is 17.5 and 17.5. I always wanted a cute like that. That's beautiful. Now, here we go. One extra step. It's not even a hard step, though. First answer is just 17.5, right? But it's not theta that equals 17.5. It's actually 2x plus 60. It's what's in the yellow that equals 17.5. Cool? It's actually what's in the yellow that's that. See, just like the last one, it is the same as the last one, but we have a whole algebra expression rather than just one thing. And same deal here. It's 2x plus 60 equaling this one, which is 180 less 17.5. Because I made a mistake last time. I'm going to go careful here. 180 take 17. I'm not making another mistake. One mistake per video is the max. 162.5. This is 162.5. So the only difference is our algebra expressions there. Now that doesn't bother us. We're going to use the mathematical implication sign, which means that x is going to equal 17.5 plus 60 equals, divided by 2 equals, SD equals 38.8. 38.8 is our first principal solution. Similarly here, 162 point. I've just made another mistake, haven't I? Oh my god. I just said one mistake per video and I've just done a mistake. I know, this is outrageous. Okay, sorry, I made a mistake. Let's go talk through this really slow. 17.5 take away 60, which is my mistake, divided by 2 equals negative 21.3. That's better. There it is. Negative 21.3, which isn't even in our range, but no bother, just leave it to it anyway. 162.5 take 60 equals, divided by 2 equals, and we've got 51.3. 51.25, which I'm calling 51.3. So that's what we've got as our two principal solutions. Now, unfortunately, unfortunately, one of them isn't even in our range, but we're not too bothered about that, because we know how the period works. Now, the period of sine is usually 360 degrees, but what's happened here is we've been shifted left 60 places by the plus 60, but we've also had a horizontal squeeze of factor 2. Well, the moving left to right doesn't affect how wide sine is, so we still just have to divide it by 2. The 60 doesn't play a role in the period. The 60 only shifts the function. It's a translation, not a stretch. So 360 divided by 2 is 180 degrees. And now we just are going to start popping 180s onto each of these guys until we get out of the range. So minus 21.3, start with it, negative 21.3 plus 180 equals my first solution of 158.7. Okay, plus 180 puts us out of the range, okay? Because that was 338, and this range only maxes out at 180. Okay, 53.1 as well, or 51.3 as well, I should say. Plus 180 makes 231.3. 231.3, which is also in itself out of the range. So weirdly enough, this, my buddies, because of the shifts and because of everything weird about this function, it doesn't have the 4 answers that you'd expect. It only has 2. That's not an answer either. All the ones that are out of the range, get rid of them. It only has 2 answers. The 2 answers, buddies, are simply these two. Theta equals 51.3 and 158.7. So while the answers that were out of the range did help us, the one thing that they did help us. The one thing that didn't work, it did help us. We don't actually use those answers. We only need the 2 that were in the range. So we did use the ones that were out of the range, but the ones that are in the range are the only ones that count. So that's it, my buddies. Tough topic. You'll have to let me know. I'm going to give you an extra revision lesson already. That's a given. But you'll have to let me know if you want it now or if you want to do one more topic to then have it. Okie doke. Your work for today is this, page 218, question 1 and 3, because they're both these kind of practice questions of normal difficulty, 4 to 8 hard questions that might involve looking at a graph. So that's it from me. Very good luck. Do a really good mix for me. And tell me in the comments or whatever next time if you want a revision lesson yet, or if you want to do one final topic to then have a big solid revision lesson with everything. Cool? So that's it for me. Bye, buddies!